Imagine you hire like a team of 5 brilliant AI agents.
Right.
You put them in a virtual room to review this high-stakes legal contract, and you assume, well, their combined computational brain power is going to catch every single error.
You'd think so, yeah.
But according to the latest research, you haven't actually reduced your risk at all. You have actually just mathematically guaranteed a hallucination.
Yeah, it's wild how counterintuitive that is.
Exactly. And today, we are taking you into this massive fundamental shift happening in technology right this second. We're exploring how AI is moving away from being, just a single isolated assistant you chat with, and is instead forming these entirely autonomous, multi-agent computational collectives.
Which changes everything.
It really does.
Yeah.
To understand this shift, we're dissecting this incredibly fascinating paper. It's titled Computational Collectives: The Organizational Behavior of Agentic AI by Jonathan H. Westover, PhD.
It's a great piece of research.
Yeah, and the big takeaway we're exploring today is that companies are realizing they have these new AI teams, right? And they're trying to structure them using traditional human corporate structures like hierarchies and committees, and it is just failing in ways nobody predicted.
Failing spectacularly, honestly.
Okay, let's unpack this. Before we get into why human structures are breaking down in the digital world, I feel like we need to define what exactly these AI collectives are and, how they actually operate in the wild. Because we are far beyond simple predictive text at this point.
Oh, absolutely. We've crossed this threshold from basic autocomplete into what the paper specifically defines as agentic AI.
Right.
And agency in this context implies goal-directed behavior. So it's not just about a model, classifying a text input or answering a single prompt anymore. Agentic AI has actual planning capacity.
Meaning it can sort of think ahead?
Exactly. Given a complex objective, it can break the goal down into discrete steps. It can select the appropriate external tools for the job, like, say, a web scraper or a database, query generate intermediate outputs, and then continuously evaluate its own progress until the objective is actually met.
Wow. And the collective aspect seems to be where this scales up exponentially, right?
Yeah.
Organizations aren't just deploying one of these goal-directed agents. They are spinning up like entire coordinated teams of them to handle full workflows.
Yeah, the transition from single nodes of computation to these ecosystems of artificial intelligence is just profound. The paper points out that these multi-agent systems consist of highly specialized roles. You have planners, reviewers, synthesizers, memory managers.
So they have actual job descriptions.
Pretty much.
Right.
In a modern legal tech system, for instance, you don't just ask one AI to read a contract. The architecture dictates that one agent's sole operational purpose is to retrieve relevant precedent documents. Another agent is specialized purely to extract specific liability clauses from the text. Then a third agent is designed solely to classify the risks of those exact extracted clauses.
Right, and then I assume someone has to put all that together.
Exactly. A fourth synthesizes those classifications into a cohesive summary. They are coordinating interdependently, passing data back and forth well before a human ever even sees the final output.
It's kind of like moving from using a really smart Swiss Army knife, where it's just one tool doing a bunch of things sequentially, to managing a fully staffed factory floor where every single agent has a specific station and a highly optimized job.
That is a perfect way to visualize it.
But wait, if they have distinct roles and workflows and specializations, do these collectives legally or sociologically count as an actual organization?
Well, the paper addresses that exact boundary. Legally and sociologically, the answer is no.
Okay, I figured.
Yeah, I mean, they do not have employment relationships. They don't form a distinct professional identity, and they obviously lack any kind of moral accountability, but they absolutely exhibit organizational behavior.
Meaning they act like an organization even if they aren't one on paper.
Precisely. They engage in patterned, consequential coordination that functionally resembles how human organizations divide and conquer complex work. They decompose tasks, they manage interdependent outputs, they try to detect and correct their own internal errors.
And I guess this matters deeply to anyone listening right now because these agent collectives are currently making intermediate decisions that end up embedded in human workflows.
Right. They are producing the initial code patches or the first draft of the legal review or the synthesis of clinical evidence. Real, actual people are legally and professionally accountable for those outputs.
So if these agents act like an organization and they're executing organizational work, I feel like the natural human instinct is to just give them a traditional human org chart. We instinctively want to assign like a manager agent, a few worker agents and maybe a committee to review the final product. But you mentioned earlier this is actively degrading system performance.
Yeah, the breakdown happens because of this core concept the paper introduces called contextual transaction cost.
Contextual transaction costs. What is
Yeah.
that exactly?
Well, in a human organization, we coordinate through shared history, professional norms, informal correction. If a junior analyst hands a manager a report, they share a vast amount of unspoken context about the client, the firm's goals, the industry.
Right, humans can read between the lines.
Exactly. Agent collectives, however, have to explicitly serialize, retrieve, and validate context every single time information crosses a boundary from one agent to another. So the contextual transaction cost is the severe penalty measured in computing power, latency, error rates, and lost information of trying to preserve the task's context as it moves through a digital pipeline.
Oh, I see. A human pipeline assumes the person receiving the work already knows the background. If an agent summarizes its work and passes it to a manager agent, I would imagine the manager agent only knows what is explicitly written in that summary. All the foundational facts are just stripped away.
The sequential pipeline, which is a staple of human factories, is disastrous for AI for exactly that reason. Agent A performs a task, compresses the output into a summary, hands it to Agent B. Agent B performs its task on that summary, compresses it further, and hands it to the manager, Agent C.
And by the time it gets there, there's nothing left.
Right. By the time the data reaches the manager agent, the information has been bottlenecked so many times that vital evidentiary details are completely lost. A manager agent cannot synthesize data or catch errors if the workers beneath it summarized away all the underlying facts.
That makes total sense. And the paper actually cites a 2026 computational study by Liu on this specific phenomenon, right? Looking at the data, the performance drops when using human structural templates are just staggering compared to more adaptive architectures.
They really are.
But, okay, I have to push back a little on the failure of the committee structure. In the human corporate world, we use committees specifically to reduce errors. We intentionally bring in diverse viewpoints, someone from finance, someone from legal, someone from engineering, to pressure test an idea from multiple angles. Why does an AI committee suddenly become an echo chamber that just hallucinated the wrong answer?
What's fascinating here is the illusion of diversity, or what researchers call a lack of epistemic diversity.
Epistemic diversity.
Yeah, epistemic diversity refers to the variance in how different entities acquire, process, and validate knowledge. If you put 5 human experts in a room, they inherently possess high epistemic diversity. They have totally different lived experiences, varied educational backgrounds, distinct cognitive biases.
Right, they literally think differently.
But if you put 5 AI agents in a committee and they all share the exact same underlying knowledge representations, meaning, they run on the same foundational model like GPT-4 and were trained on the exact same data, they do not possess genuine epistemic diversity.
Oh, wow. So there are essentially just 5 instances of the exact same brain trying to check its own math.
Exactly. And it creates a catastrophic feedback loop. Because their neural pathways and training data are identical, they produce highly correlated outputs. If Agent A makes a probabilistic error on a really complex problem, Agents B, C, D, and E are mathematically predisposed to make the exact same error.
So they just all agree on the wrong answer.
The committee will vote unanimously that the hallucinated answer is correct. And this structural imitation creates a highly dangerous false confidence for the human reviewer at the end of the line. The human sees that 5 different agents verify the output and assumes it must be bulletproof, not realizing they just received 5 highly correlated guesses without any real independent verification.
That is terrifying. So the pipeline method is basically like playing a giant game of telephone where the story gets distorted and compressed at every handoff.
Yeah.
And the committee method is just 5 clones aggressively agreeing on the same bad idea. So if human hierarchies and human committees are out, how are the most successful organizations actually structuring these computational collectives?
The strongest empirical evidence points to an architecture fundamentally different from human structures. It's known as a shared state architecture. Instead of agents passing messages or summaries down a sequential pipeline, all agents operate simultaneously around a durable, shared digital object.
Wait, the paper mentions a Blackboard memory system in relation to this. What exactly is a Blackboard memory?
Think of a Blackboard memory as a centralized, structured database hub that sits right in the middle of all the agents. Instead of Agent A emailing a draft to Agent B, both agents just stand at the Blackboard.
Okay, I'm picturing it.
When Agent A discovers a fact, it writes it to a specific field on the Blackboard. Agent B is constantly watching the blackboard, and when it sees that field update, it instantly begins its own specific task, writing its findings to a different field on that exact same board.
Oh, so it's like everyone collaborating live in a highly structured Google Doc rather than forwarding document versions back and forth.
That analogy captures the mechanics perfectly. In the Liu 2026 study we talked about,
Hmm.
deploying a shared state Blackboard memory improved efficiency by 59% over traditional sequential pipelines and an astonishing 4,400% over the AI committee structures.
Wait, 4,400%. That improvement over committees suggests that the traditional committee structure isn't just slightly inefficient for AI, it's actively destructive to the task.
It is destructive, yes, because it multiplies transaction costs without adding any value. Let's look at the Microsoft legal example detailed in the research.
Yeah, that was a great case study.
Microsoft implemented a shared state system for complex contract review. Instead of agents chatting with each other in natural language, they used what they call shared legal objects. This is essentially a structured JSON file of data format that machines read very easily.
Right.
One agent's only job is to retrieve a contract and populate the relevant jurisdiction field in that file. Another agent scans the text and continuously updates an identified clauses array. A third agent reads those clauses and updates a risk flags field.
So they're all modifying the exact same central context simultaneously, which means no predecessor's information is ever summarized away or lost in a handoff.
Exactly. And the result from Microsoft was a massive reduction in contract review cycle time by 35%. But more importantly, the architecture natively preserves the evidentiary context.
Oh, because everything is still right there on the blackboard.
Right. When the human attorneys finally looked at the output, they didn't just get a black box summary declaring a contract risky. They could trace the exact path on the shared object to see which specific clause triggered which specific risk flag.
Wow. You are building a permanent chain of evidence rather than a fleeting chain of opinions. That seems incredibly stable for routine work. But the paper also dives into adaptive organizations, where the structure isn't fixed at all, right?
Yes, and Stripe Financial Operations provides the premier example of an adaptive meta-organization. Stripe uses AI for transaction monitoring and fraud detection. But rather than forcing every transaction through the same rigid multi-agent process, their system acts as a dispatcher that reshapes the collective's architecture based on the specific nature of the incoming task.
Really? How does the system even know when to alter its own structure?
Well, the meta-organization agent rapidly classifies incoming tasks by risk and novelty. If a transaction is routine, say a $10 coffee purchase in a user's hometown, the system defaults to a very simple single-agent execution path to minimize computing cost and latency.
Makes sense. You don't need a whole team for a coffee.
Exactly. But if the transaction is highly complex, unusually large, or originates from a flagged IP address, the system automatically triggers a structural metamorphosis. It spins up an adversarial multi-agent review process right on the fly.
That's amazing.
And by adapting the structure to the task, Stripe reduced false positives by 25%, while simultaneously improving their true fraud detection by 15%.
That is literally the holy grail in financial tech. You create less friction for legitimate users and drastically more friction for bad actors.
Exactly.
But this brings us back to the committee problem. If Stripe is spinning up multi-agent reviews for complex tasks, how are they avoiding that false confidence echo chamber? If committees fail because the agents all think the same, how do we, artificially engineer them to disagree?
That is the big challenge. You have to forcibly engineer epistemic diversity into the system's architecture. You cannot simply ask a single model to just role-play as a devil's advocate.
Right, because it's still the same brain.
Exactly. The paper highlights a brilliant architectural solution from Cleveland Clinic Diagnostics. They deployed AI to assist with complex medical diagnoses, but they were acutely aware of the risks of premature diagnostic closure.
Which was when a doctor basically settles on the first plausible answer and stops looking for alternative explanations.
Right, yeah.
So how do you prompt an agent to avoid premature closure? If the data points to a specific disease, the model's probabilistic nature will naturally want to converge on that exact answer.
Well, Cleveland Clinic built a strict adversarial verification architecture. The initial diagnostic agent analyzes the patient data and generates a hypothesis, but the review agents are engineered to be entirely distinct entities. First, they use completely different foundational large language models. Perhaps the first agent is a GPT variant, while the adversarial reviewer is a specialized llama model.
Oh, interesting.
Second, they're hooked up to entirely different retrieval databases. So one might query a repository of recent clinical trials, while the other strictly queries historical pathology reports.
So you are fundamentally altering their underlying brains in their libraries so they cannot mathematically correlate their errors.
Yes. And then you apply the system prompt. The review agent is not asked to just quietly check the work. It is explicitly given a hostile persona, like, you are a skeptical peer reviewer. Your sole objective is to find edge cases, contrary evidence, and logical flaws that invalidate the initial diagnosis.
Wow, so it's actively trying to tear the first diagnosis down.
It is forced to request alternative diagnoses and demand more testing. This architecture forces genuine, independent verification from machines. And the Cleveland Clinic pilot actually reduced diagnostic errors in complex, ambiguous cases by 30%.
That's incredible. The technology is just incredibly potent when structured with shared states, adaptive meta-orgs, and engineered adversarial reviews. But all of this perfect, isolated computational architecture eventually has to hit the real world.
It always does.
These agents generate outputs, and those outputs land on a human professional's desk. How do organizations safely manage the boundary where the computational collective ends and human legal accountability begins?
This boundary is what the paper refers to as the interface organization. You cannot simply take a massive, opaque, multi-agent collective and bolt it onto a human workflow. You need a highly structured interface, and the cornerstone of that interface is the deployment of transparent traces.
Okay, when you say trace, I am immediately picturing a log file. But a standard server log is completely unreadable to a human lawyer or doctor.
Right. A transparent trace is different. It's essentially a highly structured, machine-readable, yet human-interpretable audit trail. Organizations need logs of every single action the collective took, every external tool it called, the exact paragraph of evidence it pulled from a database, and crucially, every area of mathematical uncertainty it flagged during its process.
So it's not just providing the final answer, it is exposing the entire logical journey.
Yes.
But is there a real-world regulatory environment actually accepting these traces right now?
Actually, the UK Financial Conduct Authority recently ran a pilot program for regulatory filings that totally proves this concept. Financial institutions were asked to submit their complex AI-generated compliance documents, but with a brand new requirement. They had to submit the documents with the agent traces permanently attached.
Wait, so the government regulators didn't just see the bank's final compliance claim. They could see the exact math the AI used to justify that claim.
Precisely. Human examiners could instantly open the trace and see exactly how the AI interpreted specific regulatory rules, what historical evidence it relied on, and exactly where human experts at the bank had to step in and override the system.
That's huge.
It massively improved the efficiency of the regulatory review because the examiners did not have to reconstruct the analysis from scratch to find the flaws. They simply audited the trace.
So what does this all mean for the human workforce? We talked earlier about the legal tech examples. If these computational collectives are doing all the heavy lifting, the document retrieval, the initial drafting, the risk classification, how does a junior lawyer or a junior engineer ever learn the ropes of their profession?
That's the million-dollar question.
Because the baseline grunt work has traditionally been the forge where we train junior employees, right?
If we connect this to the bigger picture, we are witnessing a massive shift in professional jurisdiction. The paper looks closely at how the law firm Latham & Watkins handled this exact existential workforce issue. They built a tiered interface organization. Routine AI outputs, the simple contracts, are validated very quickly. But for novel or highly complex issues, the interface utilizes an automated escalation protocol that routes the trace to senior attorneys.
Okay, but where do the junior staff fit into that workflow if the AI is doing the initial drafting and the senior partners are handling the complex escalations?
Well, Latham & Watkins implemented what they call agent audit rotations. Junior staff now learn their domain, the intricate details of corporate law and contracts, not by writing them from scratch, but by forensically inspecting the AI's transparent traces.
Well, that's a flip.
A junior associate who previously spent 12 grueling hours reading a 200-page M&A contract to find one bad clause now oversees a collective that processes the document in 3 minutes. The junior's job is to look at the trace where Agent 4 flagged a non-compete clause, see that Agent 4 relied on a specific definition in Section 2, and determine if the AI's logical leap was legally sound.
I see. So they're learning by critiquing a system's logic. Rather than by drafting the baseline text themselves, they're learning to spot structural weaknesses and evidentiary gaps.
Exactly. Their value to the firm shifts entirely from routine execution to high-level validation and strategic judgment. The data from the paper shows this actually decreases the cognitive load on the humans, provided the AI traces its evidence properly.
Because they aren't bogged down in the mechanics of formatting.
Right. The junior lawyers aren't context switching between reading, typing, formatting, and analyzing. They are operating strictly in an evaluative mindset. The Latham and Watkins interface protocols improved complex contract turnaround by 25% while actively accelerating junior professional development. They are doing highly focused strategic review work from day one.
That is just fascinating. We started this deep dive by looking at solitary AI assistants and moved into the vastly complex ecosystem of computational collectives. We discovered why forcing these agents into human corporate hierarchies and committees causes catastrophic context loss and hallucination correlation.
Yep.
And we explored how shared state blackboard memories, engineered adversarial reviews, and transparent traces allow human professionals to safely harness and audit this immense power.
Yeah.
I mean, whether you are prepping for a board meeting, managing a massive technical team, or just trying to navigate the shifting landscape of your own career, understanding how AI agents communicate with each other is now just as critical as understanding how they communicate with us.
Absolutely.
Here's where it gets really interesting, though. We have spent this time analyzing structures, traces, outputs. But there is a deeper, almost philosophical implication hidden in this research regarding the future of organizations themselves.
Yes, there is. The research frontiers outlined in Westover's paper raise a profound question that I believe every professional and executive needs to ponder.
What's that?
If the collective knowledge of your organization, the specific daily routines, the unique problem-solving methods, the historical memory of how things are done increasingly resides in AI prompt libraries, structural validation rules, and specialized agent memory banks, rather than in the biological minds of your human employees, who really owns your organization's expertise?
Wow. If the artificial collective becomes the factory, the workers, and the memory, what exactly is the firm?
Exactly.
Well, thank you for joining us on this custom deep dive into the organizational behavior of agentic AI. We hope it gave you the insights you need to understand the mechanics behind the next wave of technology. Keep questioning, keep learning, and we will catch you on the next deep dive.